Hey friends, check out this interesting exercise. We have to find the shaded area of this figure. Let's do it. First, let's review what we have. Here we have a quarter circle. Notice we have 90 degrees for this quarter of a circle. We also have a larger quarter circle here. Alright, let's also mark the 90 degrees over here. We also have a semicircle over here that is empty. What we'll do is add up the areas, sum up the total area, and subtract this empty area here. For that, we're going to erase this 12 here, which is the entire base over here. So let's erase it and say that this part here, notice that it's the radius of this quarter circle. We'll call it x. Very good. And from here to here, how much was it? Well, if this whole thing was 12 and we take away x, then this part is 12 minus x. Excellent. Now from here to here, how long is it? It's x as well because it's the radius of this quarter circle. Very good. Alright, so from here to up here, what will it be? What will be the diameter of this empty semicircle here? Well, we already know this part here is 12 minus x. 12 minus x is this entire line here. And if we take away this little piece that measures x, then we're left with minus x. This part from here to here is 12 minus x, and minus x again gives us minus 2x. Therefore, the diameter of this empty semicircle is 12 minus 2x. Excellent. Now let's note here that the shaded area is equal to the total area. Let's put here total area minus the area of this semicircle. The area for the semicircle will symbolize this way. It's not a zero, but a circle. Alright then, the shaded area will be equal. What will be the total area? The total area is the area of this quarter circle we have here. Notice, the area of a quarter circle plus the area of this other quarter circle, so plus the area of a quarter circle, and we subtract the area of a semicircle. Alright, remember that the radii for each one of these are different. Alright, we have that the shaded area is, how do we write the area of a quarter circle? The area of a full circle is pi times radius squared. Since we are talking about a quarter, it's then over 4, plus the same thing, right? Again, remember that it's a different radius, radius squared over 4. And finally, the area of a semicircle is pi times the radius squared, but over 2 instead of 4, right? Semicircle. Very good. So then, remember that the radii are different, so we can't just factor this out. We have the shaded area equal to pi. First, we'll start with the radius of this quarter circle here. The radius is x, so we have x squared. All of this here over 4, plus pi times the radius squared again. But now we're talking about the radius of this larger quarter circle. The radius is this here, as it measures from here to here. So we have here 12 minus x squared. Remember, it's the radius squared. All of this over 4. And finally minus pi. And let's look at the radius of this semicircle here. We have the diameter here. Let's note it down. The diameter is equal to 12 minus 2x, which is here, right? And then the radius. Remember that the radius is half the diameter. So we have to divide this by 2. 12 minus 2x, all divided by 2. And remember, well, that we can, distribute this 2 into each term. So we have 12 over 2 and 2x over 2. And finally, we have that the radius is 12 over 2, which is 6 minus. Simplifying this 2 with this 2, we have x. Great, right? Now we have the radius of this empty semicircle, so it's 6 minus x squared. All of this over 2. Very well. And notice that in almost all cases we have pi over 4. Here we just need this 2 to become 4 to have pi over 4 too. And how we can make it 4 is very simple. We multiply this by 2 and divide it by 2. and we technically haven't changed anything, right? Because 2 over 2 is 1. Yes, so multiplying 1 by this doesn't change anything. Very well, but it helps to solve the exercise. So we get that the shaded area is equal. We can directly multiply this 2 here, and this 2 multiplied down here gets us 4. And then we can erase this here. And now we have pi over 4 here, pi over 4 here, and pi over 4 here. Let's factor out the pi over 4. Pi over 4, common factor of what? Of x squared, the first term. Very well. Notice, multiplying this by this gives me this here, right? Plus, if we factor out the pi over 4, we have this binomial, 12 minus x squared. And if we take pi over 4 from here, then we're left with this 2 here, multiplied by this binomial squared times 6 minus x squared. Magnificent, right? And all of this here is in parentheses. Very well. So we have that the shaded area will be equal to pi over 4, pi over 4. Very well. Multiplied by x squared we have here. Very well. We have x squared plus we have a binomial squared. The first term squared would be 12 squared, which gives us 144. Minus double the product of the first by the second, which would be 2 times 12. That gives us 24, and times x, 24x. Very well. And the second term squared would be plus x squared. Then we have minus 2, and we're going to develop this binomial. The first term squared would be 36 minus double the product of the first by the second would be 12x. And finally, plus the second term squared would be plus x squared. All this in parentheses here, we're going to multiply using the distributive property. Minus 2 times 36 gives us minus 72, then minus 2 times minus 12x, minus times minus is plus, and 2 times 12 is 24, 24x. And finally we have here minus 2 times x squared, which gives us minus 2x squared. Excellent, right? So we can erase this here and replace it with this here. We delete, then we erase this here, and we are going to put minus 72 plus 24x, and finally minus 12x squared. Let's erase this here, and we are going to simplify. Better said, eliminate. And look what a marvel, we have x squared and x squared. That gives us 2x squared. And here we have minus 2x squared. Goodbye 2x squared. Very well. Here we have 24x and 24x, bye-bye. And here we have 144 minus 72. That gives us 72. Ladies and gentlemen, from all of this we are left with 72. We can say that the shaded area is equal to 72. We multiply by this pi and divide by 4. Here half of 4 is 2. Half of 72 is 36. Half of 2 is 1. And half of 36 is 18. And ladies and gentlemen, by Newton's beard and the power of Grayskull, we have here that the shaded area is 18 pi square units. Fascinating, right? This is the shaded area of this phenomenal figure. Let me know in the comments if you liked the video, and don't forget to subscribe and give it a like so you don't miss the upcoming challenges. See you another time. Bye bye.